everyone, welcome back. And today we are going to discuss about what do we mean by the order and degree of a differential equation. And also what do we mean by a differential equation to be linear or non-linear. And also what is the concept of solution of a differential equation. So let us start. So first of all, I would like to define what do we mean by order of a differential equation. Order of a differential equation. So the order of the differential equation is defined as the coefficient of highest derivative, the coefficient of highest derivative that involved or present in differential equation or in equation is called order of that differential equation. Just for example, let a differential equation to be d3y upon dx to y is dependent variable and x is independent variable plus d2y by dx plus x to the power 4 into dy by dx plus 8 equal to 0. So as I have said that the coefficient or the highest derivative present or the coefficient of the highest derivative present in the differential equation. So this is d3y upon dx3. So the highest coefficient is 3. Highest coefficient of derivative is or derivation or differential is 3. So its order is 3. Okay. And for any differential equation, however it looks like, the order is defined in same way. The coefficient of the highest differential present in the differential equation. Now let us see what do we mean by the degree of a differential equation. Degree of a differential equation. So we define the degree of differential equation for only those equations which are in the form of algebraic functions or their derivatives are or dependent variable is in the form of algebraic functions only, or the coefficients, or we can say the terms which are derivative of dependent variable with respect to independent variable are in the form or in the form of algebraic functions only. So and how do we define degree? So first of all, degree is defined only for those equations in which our dependent variable, that is dv, is in dependent variable or its derivative with respect to independent variable is in the form of algebraic equation only, or algebraic function. Algebraic function. Okay, and now we define degree. Degree is defined is the power of the highest differential coefficient, or you can say the power to the, or the power of the term whose which have been defined is the order. So for example, this, if in this case the term which have the highest derivative is this, so the power of this term is in this case 1, so the degree of differential equation is 1. Now let us take one more example, that is d4y by dx4 x cube plus 4 d3y upon dx3 square whole power 1 by 4 is equal to 0. So in this case what we have to remember is that the dependent variable and all its derivative must be free from the fractional powers. Its power is 1 by 4. If we talk about what is the order, so order is clearly 4. If we talk about the degree, then what, first of all what we have to do, this differential equation, in this differential equation the dependent variable and the derivative of dependent variable with respect to independent variable must be function or the algebraic functions. In all case we don't define the degree, so this or the each term which is the in the differential form must be free from the fractional power. So in this case the fractional power is fractional, that is 1 by 4. So what do, we take the power 4 both the sides, so this will be d4y upon dx4, that is x cube into plus 4 d3y upon dx3 whole square is equal to 0. So the power or the degree is defined is the power of highest derivative, or the term that is highest, in this case the coefficient or the term with the highest derivative is this, so its power is 1, so its degree is 1. For the better understanding we would take many examples. Now let us look what do one mean by a differential equation to be linear and non-linear. So what do we mean by linear? So a differential equation is said to be linear if we can write the differential equation in this form. Which form? That is a naught of x, this means some function of independent variable, because x is independent variable, into dny by dxn. What it means, that the nth derivative of dependent variable y with respect to x plus a1 of x, this means this is also function of x, into dn minus 1 y upon dxn plus so on an an into y plus some constant is equal to 0. If we cannot write the differential equation in this form, then the differential equation will not be linear. A differential equation will be linear if we can write that in this form. Okay, and so what does it mean? The a naught, a1 and these terms are function of x, so these can take any value. It itself it can take constant value or any function of x, and this n can take any value, that is n belongs to set of natural numbers only. N can take values only 1 2 3. Okay, so if we can write a differential equation in this form, then we say that this is a linear differential equation. And a differential equation is said to be non-linear if it is not linear. If it is not linear, then we say it is non-linear. Now, as we have seen that a differential equation, if the order of differential equation is n, then now let us talk what do we mean by solution. Okay, solution of a differential equation. So any function of independent variable x, or whatever we take rather than x, any function of independent variable is said to be a solution of a differential equation if it satisfies the equation. What do you mean by satisfies the equation? Let a differential equation be d4y by dx for any function of that is f1 of time x plus, or we can take any order. Okay, we are taking general equation of nth order, and f2 times dn minus y, this is function of x, and dx n minus 1, so on. So a solution y is equal to g of x is said to be a solution. What do we take? We find out the nth derivative of this function g of x and put it here, and n minus 1th differential and put that here, and so on. Whatever we want, we take the derivative and put this in this differential equation, and if it satisfies this condition, then we say that this y is equal to g of x is a solution of this differential equation. Okay, so now consider, we know that if we solve a differential equation of order n, then we need n arbitrary constants. Okay, because why do we need n arbitrary constant? Generally we can ask or argue that if a differential equation have the order n, then to find out the solution or to solve the equation, we need to integrate that equation n times, or we have to perform integration n times. And we know that when we integrate any function with respect to independent variable, we need one condition to find out the value of function, because we know the difference only. That is, we need a condition which satisfies the differential equation. So just for simplicity, that is dy by dx is equal to x. Okay, so if we want to solve this, uh, we solve this, we can write dy is equal to x times dx and integrate both terms, where y goes from here to here. So this limit, for this case we need a limit, okay, from here to here. So this limit puts, or due to this limit, let from y1 to some y or y2, okay, from here to here, x1 to x2. So this is y2 minus y1 is equal to x2 minus x1. So the value of this y2 will be y1 plus x2 minus x1. What does this means? This means that we need this the value of dependent variable one at one more point, that is called the arbitrary constant. If we integrate this in general without any limit, then we write down this is c, or a arbitrary constant, and we have discussed what do we mean by a arbitrary constant. So we need one condition. So if the differential equation have the order n, we have to perform n integrations. This means that each integration will put one arbitrary constant, and so we, for a solution of nth order differential equation, we need, in general, we need n arbitrary constants. So such a solution which contains the arbitrary constant just equal to the order of differential equation is called the general solution, or the most general solution of that differential equation. Okay,